Functions, domain and range. This is a very interesting example. I'd like you to read the question, pause the video, answer, and then look into my suggestions. The question is, use vertical line test to justify which graph is a function. State domain and range for both the relations. Now, as far as the vertical line test goes, we need to draw a vertical line and check if it could go through 2 points. Well, there's possibility here. So if I draw a vertical line at this place, it actually goes through just 1 point, and this is this point. That one is a hole. It is not included, right? So therefore, from the vertical line, we can always say that this is a function. Okay, so this is indeed a function. Now let's check the other half. The next question. Now here if I draw any vertical line, it will pass. But how about this place? If I draw a vertical line somewhere here, as you can see, it passes through 2 points. And any vertical line, if it passes through 2 points, then it is not a function, right? So this one is not a function. So that is how we can check with the help of vertical line whether the given graph is a function or not. The second part is, let's state domain range. Domain is all possible x values. Now as you can see here, the possible x values are when x is less than -3, right, up to infinity. And -3 is actually included, right, but at -3 the y value is -4, and we have continuity till 3, right? So that means we are including, we say x belongs to real numbers where x is less than equal to, since 3 is included, 3, right? This is first part, right? Everything before 3 is included. But we have one more value of x, and that is x is equal to 4, and then x is equals to 4, right? So that is how we can write domain for this function. So x is less than equal to 3 and x equals to 4. 4 is a part of domain, right? That point. How about range? Range is all y values. So what we observe here is that the y values between 2 and -4 are included. So y belongs to real numbers, so that y is greater than equals to -4 and less than equal to 2, right? Since these solid things means included. And what else? And you'll also observe that everything greater than 3 is also a part of range, correct? And y greater than 3, not including 3 because this is a whole, and greater than 3, right? As far as this point is concerned, y value is -2, which is already included in the range specified earlier. You see that. So that is how we are going to give range for our function. It is important to note that domain and range could be in parts, kind of piecewise, okay? Now we'll exploit this strategy more in the second example. Here we know it is a function. Now let us see what is the domain of this function. Now domain here is, since these are connected solid lines, x belongs to real numbers. Okay, that's first part. And second, what are the possible values of x? Everything less than 3, -3. So we say x less than, but not equal to, right? Since it is a whole there, -3. What else? Between -2 and 2. And also this is from 1, right? 1 onwards. So that means everything greater than -2, right? And x not including -2 but greater than -2. -2 to infinity, right? All the x values on the right side of -2. So that becomes the domain for our function. And now let's write down the range. Y values are belonging to real numbers, and y values are, if you see from here, greater than 2, all values greater than 2, right? Not including 2. So y is greater than 2, that's first part. And here what we observe is, so this point we are not very sure, let's make it solid for the time being, okay? So if it is solid, then it means that point is included. That means minus 3 is included. So we say y is less than equal to minus 3. Less than equal to, since we made it solid, right? Okay, so that is what the range is for this function, right? So it's kind of combination of two. Okay, so that is how we can write it. You could also write it in this form. I'm just writing range. When we say greater than 2 and less than equal to minus 3, we could write this as less than equal to minus 3, means from minus infinity to minus 3, that is the interval, and minus 3 is included, right? So a square bracket, union, and also y greater than 2, not including 2, that means from 2 to plus infinity. Do you see that? Not including 2, and you can never include infinity. So that is how we can write down range in another way, correct? Similarly, you could translate for domain also. Okay, I hope it's absolutely clear to you that at times domain and range could be combination of few intervals, right? I hope that example helps. Thank you and all the best.